Here in session 104, we're going to be solving different kinds of formulas, which are just different types of equations. Here I've gone ahead and made up a formula, x plus 1 over a equals b over 4. Now let's say that we need to rewrite this formula in terms of x. In other words, we want x isolated all by itself on one side of the equation. Well, we just go through and use our normal algebraic strategies to solve it. If we recognize this, we have a fraction on the right and a fraction on the left. We actually have here a proportion, so we can use our cross multiplication here. We can multiply our means times our extremes. So let's go ahead and rewrite this. We're going to have 4 times x plus 1 over, just times x plus 1. That's going to equal a times b. We need to solve for x. This phrase here is being divided by 4, so we need to divide both sides by 4. On the left side, that'll leave us x plus 1. On the right side, that'll give us ab over 4. Next, we got to remove the 1. In order to do that, we have to subtract 1 from both sides. That'll leave us with an x on the left-hand side. And then on the right-hand side, that'll be ab over 4 minus 1. That's probably good enough, but it's more advantageous or more expected that we would go ahead and take this second term here and rewrite it so that on the right-hand side we would have 4 as our denominator all the way across. So in order to subtract this 1 from the ab over 4, we have to get it so that it has the same denominator as 4. Well, we can do that by rewriting this as minus 4 over 4. So in essence, what we now have is ab minus 4 over 4. So rewritten in terms of x, x is equal to ab minus 4 over 4. So there's our formula, our equation rewritten in terms of x, and we did that by getting x all by itself on one side of the equation. Well, here's another quick one that we'll take a look at here. It's our temperature scale formula. Our formula for Celsius, C for Celsius, is 5/9 times parentheses F for Fahrenheit minus 32. So if we knew the Fahrenheit temperature, we would stick in that value here for F, calculated it out, and that will then tell us what our Celsius temperature is. Well, let's say I want to know what our formula is for finding the Fahrenheit degrees. What if I already know my Celsius, but I want to find out what that is in Fahrenheit? Well, in order to do that, we've got to get F for Fahrenheit all by itself on one side of the equation. Well, here, this phrase, F minus 32, is being multiplied by 5/9. So to undo that, we have to multiply both sides by 9/5, the reciprocal of 5/9. If we multiply the left side by 9/5, that's going to give us 9/5 times C. On the right side, our 9/5 times our 5/9 will be 1, and 1 times F minus 32 is just F minus 32. We're almost there. The F is not quite by itself. It's having a 32 subtracted from it. So to undo that subtraction of 32, we need to add 32 to both sides. On the left-hand side, that'll give us 9/5 C plus 32. And then on the right-hand side, when we add 32, that negative 32 and positive 32 will cancel, and we are simply left with an F on the right-hand side. So our formula for finding out the temperature in Fahrenheit, if we already know the Celsius, is F equals 9/5 Celsius, 9/5 C plus 32. One more here. 2b over x minus a over b equals 3a over x. We have fractions again here. Each of our terms has a fraction in it. So what we need to determine is the least common denominator. Well, we have x, x, and b. The least common denominator here is going to be bx. So what we need to do is take bx times both sides of the equation. So that's going to be bx times 2b over x minus a over b. And on the right-hand side, we're going to have bx times 3a over x. Next, let's go ahead and multiply out, distribute through. Bx times 2b divided by x. If it helps you to put a 1 under the bx, go ahead. We can see here that this x and this x are going to cancel. So when we take bx over 1 times 2b over x, the x's cancel, and what that's going to leave us with is 2b squared over 1, which is just the same thing as 2b squared. Next, when we take our bx over 1 times our minus a over b, this b here is going to cancel out with our b here. So what that's going to leave us with is minus ax over 1, which is just the same thing as minus ax. Then over on the right-hand side, we can see here that when we multiply this bx through, that's going to cancel this x down here. What that'll then leave us with on the right-hand side when we distribute this through or multiply it out is we're going to be left with 3ab over 1, which is just simply the same thing as 3ab. Now what we're trying to do here is we're trying to rewrite this formula in terms of x. We're trying to get x all by itself on one side of the equation. Well, we still have an x on the left side. It's been removed from the right side, so we're a step closer here. Our variable is now on one side of the equation. So we need to undo the other things that are on the same side of the equation. Well, we need to get rid of this 2b squared. So to do that, we need to subtract 2b squared from both sides. Well, if we subtract 2b squared from the left side, that's just going to leave us minus ax. And on the right-hand side, if we subtract it, that's going to give us 3ab minus 2b squared. We're almost there now. We have a minus a being multiplied by our x, so we need to divide both sides by minus a. When we do that, we're going to be left with x on the left, and then on the right, we're going to have 3ab minus 2b squared, and we're taking that and dividing it by minus a. This then is this formula, this equation, rewritten in terms of x. X is all by itself now on one side of the equation. And then as a quick review, sometimes formulas, which are just special types of equations, need to be reworked so that the formula is in terms of a different variable. And we did that earlier with our Celsius and Fahrenheit example. To do this, simply use algebraic strategies to isolate the variable all by itself on one side of the equation. That finishes session 104.